for that cutting off, so this is now part 2. I just cut out all the crazy children that I have. But anyway, so to calculate the midline, right, we talked about how it was equidistant from the maximum value to the minimum value, and we calculate that by taking essentially the average of those points, which is the maximum value plus the minimum value, right? So we have a 3 plus -3, and we divide that by 2. So that's 0 divided by 2, and in this case, our midline is y equals 0. Okay, and when we start to vertically shift them, it's going to be important for us to be able to calculate the midline. And then also think about it too, the relationship between the midline and the amplitude. Notice that the max point is exactly 3 units from the midline, right? The midline is the equation y equals 0, and the midline is the equation y equals 0, and that's exactly 3 units from the lowest point. Okay, so thus the whole average. So now let's consider vertical shifts. We know how vertical shifts work. Essentially, if it's not grouped with x, all we're doing is taking the position of each point and we're shifting it down 5. So you go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The shape of the graph is not changing, right? It's still a cubic function, like that, right? It's just on a different location on the graph. So that exact same process, that exact same transformation is what we use for sine, cosine, and all the other trig functions. And what color do I want? I want my pink one. The pink one's really nice. Okay, so sine. You know what's nice too is every time we do our function transformations is to draw that parent function. So real quick, 0, 1, 0, -1, 0, and in the opposite direction, right? 2 full cycles of sine, so we really see the effect. Anyway, arrows. And again, if it's not grouped with x, you're just adding 2, you're just physically shifting the graph up 2. So this is your vertical shift. It is the exact same concept that we learned with regular function transformations. They're all functions, right? They're all functions. So 0, up 2. 1, up 2. 0, up 2. -1, up 2. 0, up 2. 1, up 2. 0, up 2. -1, up 2. 0, up 2. Okay? And when I graph this too, this is one way to think about it, right? You're physically shifting everything up by 2. In trig, we actually, let's make this a little darker so we can see what the heck I'm talking about. In trig, the thing about a vertical shift kind of goes back to what we were just talking about with the midline. The midline becomes really important here. Let's do blue. Okay, so your midline essentially is what's changing, right? Your +2. You could absolutely just go to your midline, right? Go up 2. I know it's 0. Midline, up 2. Put a nice dashed line in there. Really need to sharpen these. Okay, and then notice from that midline, the pattern repeats if I treat this as 0, right? 0, 1, 0, -1, 0. You can also think of it too as if this is the midline, the amplitude from the midline is 1, well, 0 from the midline, 1 from the midline, 0 from the midline, -1, and so on. So all of the same concepts are here, and I know you guys are very good at them. So I am going to go through 2 practice problems, one that's sine and one that's cosine, because I haven't technically gone through a cosine function with you. I assigned it for homework, but I think that that will be important. I also want you guys to get back into that mindset of building functions. So when we graph something like y equals 2 sine x, yes, of course, we're going to have our graphing calculators, but sometimes it's just nice to reinforce those kind of concepts of how the functions became to look the way that they do. So if I start with the parent, y equals sine x, right, that's going to be my first function. Then think about it as order of operations. You multiply before you add or subtract. So the next function I'm going to do is y equals 2 sine x. And then the last one, which will be my final one, is y equals 2 sine x minus 1. And I'm actually going to do this one. My first graph, 0, 1, 0, -1, 0, -1, 0, 1, 0. Nice sketch of the graph. Okay, and then what happens when you have an amplitude? It's the absolute value of 2 here. Well, the midline of sine x is y equals 2 or 0 at this point, right? So if I apply the amplitude, then 0 times 2 is 0, 1 times 2 is 2, and so on. Okay, so we've kind of expanded it. We still are on the midline of 0. And then this, the last function, so that's when I graphed, that's the second one I graphed. This just takes the midline and shifts it down. So now the midline is y equals -1. And here, I will graph this in purple. It just takes every line, every point from this function here and shifts it down 1. Right, this function here, down 1, down 1, down 1. And I could also put a nice new midline in there to show y equals -1. If you want to do that before you graph the points, that's fine, and then apply the amplitude, that's totally fine. We all have our way. And when I connect these, I now have my y equals 2 sine x minus 1. And also, if I were giving you a graph and said, okay, calculate the midline, you would say, well, the max value plus the min value divided by 2, which is the max here of my purple, that's 1, right? Plus the minimum value, that's 1, 2, 3, divided by 2. Well, that's -2 divided by 2, or -1, right? See how that happens right there? Okay, and last but not least, I definitely want to go over the cosine function with you guys. And what time do I have? Okay, gotta hurry. So the cosine function, again, we're going to build this function. So y equals, I'm going to do negative 1/2 in the same step because they are both multiplying. So y equals negative 1/2 cosine x, and then y equals negative 1/2 cosine x plus 3, right? So your cosine function, the pattern that the cosine function generates from the midline of 0 is actually 1, right? When I plug in 0 for cosine at that coordinate on the unit circle right here is 1 comma 0. So cosine's actually, it starts at 1. And then once you've hit that pattern at 1, guess what? 1, 0, negative 1, 0, 1 again, right? It's essentially the sine curve moved over 90 degrees. So 1, 0, negative 1, 0, 1. And we can continue on the left as well, right? It's literally, here, and I'll show you in just a second. So here's the one cycle of cosine around the unit circle. If I just shift my view, doesn't that very much resemble a sine curve? Yes, it is a sine curve, only shifted to the left 90 degrees, right? So really, when you know the fundamentals of where all of these numbers come from, it becomes quite clear as to what you need to do. So cosine here, the amplitude is 1. Now, this is not grouped with x, so I'm going to multiply all of the values, the y values, by negative 1. And I'm actually going to use a colored pencil for this. Use this ugly brown. Okay, so 1 times negative 1/2 is negative 1/2. Oh, wow, that is ugly. All right, 0 times anything is 0. Negative 1 times negative 1/2, right? So we're doing those two transformations at the same time because they're both multipliers. 0, and then 1 times negative 1/2 is negative 1/2. And we continue. 0, reflect, multiply a half, reflect, multiply by a half. Okay, so now our beautiful, well, that's not beautiful. Cosine function is flipped upside down, right? And brought into the midline by a half, right? It only can travel a half a unit from the midline than it used to. Now what we're going to do is we're going to shift the function. Where's that wonderful pink? It comes across so nicely. Okay, so that one's done, that one's done. Now, your midline shift is now y equals 3. And I'm going to take all my brown spots. That sounds funny. Negative a half. 1, 2, 3. Move it up 3, right? It's plus 3. It's not grouped with x. You do exactly what it says. 1, 2, 3. 1, 2, 3. 1, 2, 3. 3. We could also apply, I'm going to show you how to do it with the midline, right? So here's our midline. Of y equals 3, we could just apply the amplitude of negative 1/2, well, the amplitude. is the absolute value of negative 1/2. Just make sure we're very clear. That is a separate reflection. And what's this? Up. From the midline, -1, 0, +1, 0, -1. And I'm saying that because that's the general pattern. And I am also applying that 1/2, right, to it. And we can graph this beautiful graph. Start over here. And that is our y equals -1/2 cosine x plus 3. Okay? So, yes, you can graph these on Desmos.com. Yes, you can graph these just on your graphing calculator, but I think it's important to know where all of the features come from. Please follow up with the Delta Math questions. Have a great day.